Hi. In this one, we will do derivative of logarithmic functions. I will give you 4 different rules, but out of these 4 rules, if you memorize only this one, it will be enough for you. So, now, firstly, let's try to understand the rule how it happens. So, when you are given like log base of a number will be given in here like 3, 4, 5, and a function over that. If you have such that function and want to take derivative of it, it equals derivative of the function part over the same function as it is times ln of the given base, ln of the given base. So in this place, derivative of x in here should be derivative of x equals 1. So this rule is shortened over there. If you continue with this example, derivative of f of x. So now let's use rule 6. Now it's same with the rule 5, but let's do it like the rule 6 in here. Says that if there is a function in this place, derivative of that function goes in here, which is derivative of x is in here 1, so that the same function as it is in here times ln of the same base, ln 2. So now guys, pause the video, try to solve the second example. So now let's move on. I think you pause the video, you try to solve it. Let me show you what to do. Check that do you have any mistakes or not. So now here we have logarithmic function. There is a function, there is the base, so we will use this rule. What the rule says, derivative of the function part goes to numerator. X cubed power 3 will be moved before x cubed, so then the power will be decreased 1, which is x squared, and plus power 1 will be moved in here. 2 times 1 is going to be 2 times x to the power of 0, no need to write. So derivative of the function. So in denominator part, the same function as it is, which is x cubed plus 2, x cubed plus 2x, then times ln of the given base, which is number 2 over that, base 2. So now guys, try to solve this example on your own. Pause the video, try to solve it. So I hope that you paused the video. Now I'm going to continue to solve it. Look at that. What kind of case do we have in here? Here we have square of a logarithm, square of a logarithm. What is the base in here? If the base is not written over there, it is always the base 10. It is always the base 10 if it is not written. So here we are going to use combination of 2 different examples, which is we have made before. If you have such that function and want to take derivative of that function, so you do it like, we call it general power rule. You move the power before, then inside the parentheses f of x is same, and decrease the power, then times derivative of the inside part. So now we will use that idea in here. So we will move this power 2 before the logarithm, 2 times log base 10, and power will be 2 minus 1, 1, no need to write, and then inside the same function as it is, the same function, which is logarithm ex, its power of x plus x minus 1. So then times derivative of the given function, which is log base 10 of e to the power of x plus x minus 1. So now we will write the derivative of it in here as a rational expression like in this rule. So derivative of the, if you are taking derivative for logarithm, derivative of the function part, e to the power of x, derivative of it same as it is, then plus x is going to be 1, and minus 1 will be minus 0, no need to write. So then in denominator part, you write the function part of the logarithm, same again, e to the power of x plus x minus 1, times ln of the same base, ln of the number 10, which is log base e of 10. So let's move on. Here you have 2 more rules, but actually it is the same rule. For example, in here we have log base e of x, which means when you take derivative of it, derivative of x part goes to numerator part, derivative, then in denominator part you write the same function of as it is then ln of the base, which is e, which means ln e will be equal to 1, so you will have only 1 over x over that. Also in here you write the same function times ln of the given base, ln of e will be equal to 1, and you will have, so these two rules, they are just shortened by looking the previous rule 6, which means if you memorize only the 6th one will be enough for you. So now guys, please try to solve this first example on your own. Pause the video. So now I hope that you pause the video. Let me move on then. So now I am going to take derivative of this function, which is ln of x squared plus 3x plus 1. So if you have a logarithmic function and want to take derivative of it, so in this logarithmic function we have another function part over there. We write derivative of it in numerator part. X squared will be 2x plus 3x will be power 1 will come here, and 3 times x power 0. No need to write that one. So in denominator part, in the logarithm you will have another function part. You write that part same as it is, x squared plus 3x plus 1 times ln of the given base. So here we have the ln, which means log base e. Ln of e is going to be equal to 1, which means no need to write this one. So then guys, pause the video, try to solve this one, derivative of ax. So now I hope that you did pause the video and tried. Let me show you the answer, check that we had the right answer or not. So here we have a similar case with the previous page. We have all the functions inside the parentheses and power 2. It's the same rule we will use once again. We will combine the two rules. So it's going to be the same. Power 2 will go before the parentheses, and power 1 will be over there, and inside the parentheses you write the same function one more time. So then times the derivative of inside part. Here we have sum of two different functions, we may say. So derivative of e to the power of x is the same as it is, plus derivative of ln x is equal to, so derivative of the function part in logarithm is 1, and over x is going to be from the rule you may see over there in here. Let's move on then. So now guys, pause the video and try to solve this example on your own. So now I hope that you did try to solve it. So then let me show you the answer, check that you have the right answer or not. So in this one guys, we will do the combination of two different rules. So actually 3 rules, we are going 4 rules in here. The first rule that we are going to use, which is product of two functions. Here we have the product of two functions. So to be able to take derivative of it, derivative of first times second plus first times derivative of second. So derivative of first, it's an exponential function, so we will do as it is. We will do the rule of exponential function, which is first you write the same function as it is, then times, there will be 3 parts of it, then times ln of the same base, ln e it will be, so it's going to be equal to 1, then times derivative of the power part. Let's do that. Power 2 comes here, and power 1 goes there, it becomes plus 3, times the second function as it is, log base 3 to x minus 4. So here I am using the product rule, then plus, after plus you write the first function as it is, x squared plus 3x, times derivative of the second function. Here we have a logarithmic function. Inside the logarithm there will be another rule, so derivative of that rule part will be in the numerator part. So power 1 comes here, comes 2, and minus 4 will be minus 0. Then in denominator part you write that function part one more time, and times ln of the base, which is 3 in this case. So actually here we are finished, but we may take a common factor parentheses if we are able to only e to the power of x squared plus 3x, but let's not do it. Let's keep it like that. So that's all for this place.